Hello everyone. In this video we're going to learn the second method of grouping, which is called the limit grouping. Recall from the previous lesson we have learned the first method, which is called a single value grouping. I will tell you the difference between the two with the help of an example by workout, and I will show you how to do a limit grouping for a quantitative data. Let's start. It's a second method of grouping for a quantitative data, and what we do, we use class limits, and that's why it's called the limit grouping. Why when this is useful? When this type of grouping is useful, this type of grouping is very useful when we have too many distinct values, so that the single value grouping doesn't make sense. I will explain you with the help of an example. And each class consists of not a single value, but rather it's a range of values. I will explain these three bullets with the help of an example. Let me go to my blackboard. Okay, so we are starting with something called what we have done already. We have done single value grouping. Okay, we have done single value. This is what we have already done, single value grouping. And examples were, let's say I have a data that has a number of siblings. Now when I have a data of number of siblings, it won't have too many distinct values. Let's say somebody have a 0 sibling, somebody have 2, somebody have a 3, somebody has 1, somebody has 4, and so on. Maybe why? So the number of siblings, there won't be too many distinct values. I can't have a large number of distinct values. So in this situation, we have a discrete data and we don't have large number of distinct values. In such a situation, the single value grouping is a very good idea. But what happens when the number of distinct values is large? Then the single value grouping will not make any difference, will not make any sense to us. Okay, let's see what I mean by that. Let's take an example. Let's say I ask some people, let's say I ask few people, what are your yearly salary? Somebody say, okay, my yearly salary is $6,000. Somebody say, I earn $65,000. Let's say somebody says, I earn $70,000. Somebody says, I earn $90,000. Somebody say, I earn $80,000. Somebody says 70, 71. Let's say 75, 83, and let's say, and so on, right? Yeah, that's okay. So what happened? Now you note that in this situation, I don't have a single distinct value. Although these values are whole numbers, these are discrete values, but the number of distinct values is not small. So what we are going to do, we cannot make a single column for each of these values, and that will look very ugly, as we do in the case of a single value grouping. So what we do, we define classes. Like what we do now, we say, okay, let's make a category. All those people who are earning between $60,000 to $69,000, they are in this category. All those people who are earning between $70,000 to $79,000, they are in this category. And all those people who are earning $80,000 to $89,000, they belongs to this particular category. And say, let's say for the sake of discussion, just we are taking a simple example to understand, all those who are earning $90,000 to $99,000, they are in this category. So what we do, we define classes. This is a class. This is a class. This is another class. This is another class. And this is another class. So what I have done here, I have defined a range of value. It's not a single value, it's a range of values. Note that it's a range of value. It starts from 60 and it goes all the way up to 69. It's a range of values. So such type of grouping is called a limit grouping, and this is a class. This is a class. This is a technical term. A class, a range, a category, a band of values. This is the first class, the second class, the third class, and the fourth class. Okay. Now note that 70 is the smallest value that I can take into the second class. 70 is the smallest value that I can take in the first class. So the 70 is the smallest value, and 79 is the largest value that I can go in the second class. So for this reason, the smallest value that can go in a class is called the lower limit. lower limit of the class, and the largest value that can go in a class is called the upper limit. So each class has a lower limit and an upper limit. 60 is the lower limit of the first class. 79 is the upper limit of the second class. 80 is the lower limit of the third class. 89 is the upper limit of the third class. 99 is the upper limit of the fourth class, and so on and so forth. So you see all these values, we have a classes, and each class consists of a range of value instead of a single value. Okay, how we do this type of a grouping, we will take an example to understand the idea. Let's go to the example. So I explain all these stuff. The smallest value that go in a class called the lower limit of the class. The largest value that can go in a class is the upper limit of the class. And I will explain what you mean by this midpoint, the class midpoint or a class mark, with the help of this example when it comes. Okay, I will explain this. Let me take an example now. So days to maturity for the 40 short-term investment is given in this particular table. Use the limit grouping with a grouping by tens, right? To organize the data into frequency and a relative frequency distribution. Take 30 to 39, the first class. Also find the class midpoint. So we are given this data on our left side, and we have to make a distribution, frequency distribution and a relative frequency distribution. Whenever you are asked to make a frequency and a relative frequency distribution, the first thing we're going to do, we're going to create a table that consists of 4 columns. Let's create a table that consists of 4 columns. I told you in the first lecture also. So here's the table that consists of 4 columns. The first column has the name of the variable. These are days to maturity, right? And he told us take 30 to 39 as the first class. So I will start from here and I will take 30 to 39 as my first class. This is 30 to 39. Now note that he is asking us to do a grouping by tens. So grouping by tens. So what I'm going to do, this is the lower limit of the class and this is the upper limit of the class. So what I'm going to do, I'm going to add 10 in this lower limit to write all the lower limits. The 30 plus 10, 40. Then I have a 50. Then I have a 60, a 70, adding 10, 80, and a 90, right? Now we write the upper limit of all these classes. Upper limit. The same thing. We have the upper limit of the first class as 39. I will add 10. It's a 49. It's a 59. It's a 69. It's a 79. It's an 89. And it's a 99. Now you might be wondering why I stopped at 99. The reason is 99 is the largest value I have. Look at that. 99 is the largest value. There is no need for the other class. There is absolutely no, because 99 is the largest value. So that will be taken care of. Next is what I'm going to do. I'm going to make a tally here, right? What I'm going to do, I have the values here. You see these values. These are the values. And I'm going to take these values and I'm going to tally or copy here. So the 70 is the value. First value is 70. 70 will belong to this class. So this is the tally mark. I have this tally mark first. Tally mark 70, 62, 75, 57, 51, all done. 64, all these are all done. Now we have 64, 38, 56, 53, 36, 99, 67 will be in this range, 71, 47, 63, 55, 55. When we have the fifth to make a pack of a 5, it's like we do it like this: 55, 70. I'm not going to do all these. I'm going to stop this, and so that we can complete that. So I'm going to come back to you and I will finish this. So I have completed all these the tally. I have completed this tally column. Okay, so now I'm going to write the frequency. Frequency means how many time a value is appearing in our data. This is 3. 3 is here. It's a 1. It's 8. We have a 10. We have a 7. We have a 7. And we have a 4. If I add all these values, if you add all these values, the total comes out to be 40, and it has to be 40. If this was not 40, then I would have been in a difficult situation. The reason is the sum of all observations, the sum of all frequencies is always equal to the total number of observations. So how we get this relative frequency? We divide the frequency by the total. We divide the frequency by the total. We take each frequency and divide it by the total. 10 divided by 40. This is 7 divided by 40. This is 7 again divided by 40. This is 4 divided by 40. And remember, the sum of all relative frequency is always equal to 1. These are the two rules you need to remember that, right? The sum of all frequencies is always equal to the total number of observations, and sum of all relative frequency is always equal to 1. Okay. Now the last thing I would like to tell you, how we create the midpoint, how we get the midpoint. In order to understand how we get the midpoint, let's go back to my blackboard. You remember in our situation we have 30 to 39 as our first class, and we have a 40 to 49 as our second class, and we have 50 to 59 as our third class. So these are the classes. So how we find the midpoint? What we do, the midpoint of the class mark, we take the lower class limit, we add the upper class limit, and divide by 2. That's what we do. This is simple, that's simple as this. We take the lower class limits, you take the upper class limit, you add them and divide by 2. That's how you get the midpoint. You calculate this, and this is the midpoint, or what we call it as a class mark. Same for this one. Let's say if I want to find out the midpoint for this one, what I'm going to do, I'm going to take the lower class and I'm going to add the upper class limit, and I'm going to divide by 2. It's an average of the two class limit. Right? So that's how you find the midpoint for every class. In some statistical software packages, they use the midpoint when they make a graph or a histogram. So this is a good idea. You must know how to calculate the midpoint. Let's go back. So this is all we have to do. Let's confirm that we are doing it right or wrong. So this is the thing which is coming from the this is the actually provided, and this is what I have done with my own calculation. I could have shown you this simple, that's just a click of a button, but I showed you how to make it so that you are more engaged and you know how to do that. I hope you understand this idea. Thank you for watching.